So in this video, I want to introduce the consumption function. The consumption function plays an important role in the determination of equilibria in the goods market in the short run, and therefore it deserves a good introduction here. The consumption function can be looked at algebraically and graphically. Let's start out with simply the graph, and we get the intuition right, and afterwards look at the algebra. So here we have consumption, and here we have YD, which is disposable income. Let me add that here. YD is equal to Y minus T. So T are lump sum taxes that households pay, and income is their income. Macroeconomically, Y is equal to value added, namely all the income that goes to the owners of machinery and firms and such, and workers, and at the same time Y is equal to production, of course. So the value of all goods and services produced in an economy in a given time period. So macroeconomically, disposable income of households of the private sector is equal to GDP minus taxes. Now the consumption function in this CYD space looks like this. It has an intercept, a positive intercept, and a positive slope, is upward sloping straight line. So what does that mean? Well, suppose that we start out right here. That is, apologies, messing up everything here. Okay, suppose that the economy is at a point like this, then disposable income for private households would determine that C takes some value here, which I will denote with this cross on the axis. Now, if disposable income of households rises by this amount, consumption would rise by this amount. I'm going to denote this point by the circle. So the key insight is that the increase in disposable income is larger than this increase in consumption, but the increase in consumption is positive. So out of any additional dollar in income, households spend a fraction on consumption. What do they do with the rest? They'll save it. So how can we express that algebraically? Quite simple. C is equal to C0, some autonomous component of consumption, plus C1 times Y minus T. So C0 then is this autonomous component of consumption, some amount of dollars that households spend on consumption independent of their income. But then as their disposable income rises, they spend of any additional dollar a fraction C1. Very important, C1 is between 0 and 1. C1 is, of course, the marginal propensity to consume, MPC, and the name says what it does, the marginal propensity to consume. So as income increases marginally, households have that propensity to consume out of that additional dollar. So let's just take an example. If C1 were 3/4, 0.75, if then disposable income rises by $1, consumption will rise by 75 cents. The remaining 25 cents will go to savings. That is basically what the consumption function is. We can look at the consumption function though in still a little more detail. Let me add a new page and write the consumption function down here once more. Y minus t. We can, for example, expand the expression and write C1 minus C0 minus C1t plus C1y. That then means yeah, come in. Hi Diksha, how's it going?
Are you busy?
I'm just recording.
Okay, I'll see you.
10 minutes or so.
Okay.
Or
that's good.
yeah. Okay. Where was I? We can write the consumption function as a function of y directly rather than yd. That means then in terms of the graph, we'd have again a intercept here, c as a function of y that rather than yd, and the intercept would be c0 minus c1 times t. The slope of it is the same though, namely c1. Let's try that again. C and yd. So you see the difference here is just the intercept. Since we either account for taxes on this axis or on this intercept. Relevant later when we put the goods market model together, I just wanted to show it now. It is relevant though as well because we can derive from the consumption function a savings function. So let's go to that as well. Add a new page here. The savings function. So C is equal to C0 plus C1 times y minus t, and the savings function, well, what is savings? Savings is everything that is left over after you received your income, paid your taxes, and consumed. So we can therefore write S equal to y minus t minus C0. So we're using this expression to plug it in here. C0 minus C1 y minus t. And that of course can be simplified to give us a S equal to minus C0 plus 1 minus C1 y minus t. So we have a negative intercept, the negative of C0. We have a positive slope, namely 1 minus the marginal propensity to consume, or in other words, since that is as well between 0 and 1, the marginal propensity to save. The marginal propensity to save is, of course, 1 less the marginal propensity to consume. Right? So we can write S1 is equal to 1 minus C1, or C1 is equal to 1 minus S1. The marginal propensity to consume is equal to 1 minus the marginal propensity to save. How do we put that in a graph? Quite analogous to what we had previously, namely S and Y. We just need the negative intercept here, minus C0, and a positive slope, but a more shallow slope if we assume that C1 is larger than 1/2, namely 1 minus C1. And then this denotes the amount of savings. So I'll leave it at that as an introduction to the consumption function. The key is that we have a positive but less than 1 marginal propensity to consume, and that we can express that in this graph where we have autonomous expenditures on this axis as the intercept, and then the consumption rising with additional dollars of income according to C1.